GCSE Physics Boosters, Newton's second law. Okay, now I've written it like this, hopefully you understand it. Now, Newton's first law says if F res equals 0, then A equals 0, right? If there's no resultant force, then there is no acceleration. In other words, the object will stay not moving, or its velocity will stay the same. If F res is 0, then A equals 0. Now, basically, Newton's second law says that if F res is not equal to 0, then A is not equal to 0, and that the acceleration is proportional to F res. The acceleration is proportional to the resultant force. Now, Newton's second law basically means that we won't really say exactly what it means, what he said, until we've done momentum, but this will do for now. You should know by now that this sign here is proportional to. You should understand what that means. So if there's a resultant force, then there's an acceleration in the same direction and proportional to the resultant force. Consider this. Now, this car, we saw this car in the last video. Thrust and friction are equal and opposite. There is no resultant force. The car is moving at a constant velocity. Now, what would happen if the thrust got bigger? What would happen if the person driving the car put the foot down on the accelerator? Well, now the thrust is bigger than the friction. If thrust is greater than friction, then there is a resultant force. The car will accelerate. It will speed up. Similar, if the friction is bigger than the thrust. If the person took their foot off the accelerator, and the friction is bigger than the thrust, then again there is a resultant force. The car will decelerate. So basically, if there's a resultant force, then there will be an acceleration or a deceleration. Okay, its velocity will change. That's what acceleration means. Now, to investigate this, hopefully you'll have done, or you will do, an experiment like this. Now, using a trolley and pulling a trolley with a force, using maybe some masses going over a pulley, and then measuring. Now, one way of getting the acceleration of the trolley is to find its velocity after it's traveled a certain distance, and you can do that using light gates and a data logger. You're supposed to use a data logger at some point in the course. So to investigate the relationship between force and acceleration, a light gate, which is what this thing here is, that's called a light gate, attached to a data logger, and this can be set up to give the velocity of the trolley after it's traveled a certain distance. Now, if u equals 0, in other words, if the trolley starts from rest, we can work out the acceleration using this equation here. Now, you might remember, hopefully, v squared minus u squared equals 2as. Yeah, we said that in an earlier video, calculating acceleration. All I've done is I've rearranged it, and I've said that u is 0, so u squared is 0. See, the trolley has a piece of card, a 10 centimeter piece of card, and that breaks the light gate, and that lets the light gate and the computer work out the velocity of the trolley. So what we can do is we can change the force by changing the masses that were hanging on the bench pulley. You've got to, if you're changing the force, you have to keep the mass the same. Now the total mass, so a little trick is if you take masses off there, you've got to put them on the trolley. Okay, otherwise the total mass will change. You can also change the mass of the trolley and keep the force the same. Okay, so this is a kind of experiment you can do. Now, the results that you should find is that the acceleration is directly proportional to the resultant force. So the bigger the force, the bigger the acceleration. The acceleration is directly proportional to the force. That means that the graph is a straight line. It means that if you double the force, then the acceleration doubles. Okay, so the acceleration is directly proportional to the force. Now, the acceleration is inversely proportional to the mass. And that's how we write that mathematically. The acceleration, well, it's proportional to 1 over the mass. That means it's inversely proportional. And that basically means that if we double the mass, then the acceleration is half as much. Pretty obvious, really. If something's heavier, if the trolley was heavier, then its acceleration is going to be smaller. Okay, inversely proportional means that if you double one thing, then the other thing halves. Okay, so the acceleration is proportional to the force and it's inversely proportional to the mass. Now, combining those, we get F equals ma. Now, F equals ma, strictly speaking, isn't Newton's second law, but until we do momentum, it will do. F equals ma. Remember that F is the resultant force. Okay, there might be several forces acting on the object. F is the resultant force. M is the mass in kilograms, A is meters per second squared. Have a go at this. A car has a mass of 1,600 kilograms. The thrust force is 4,400 newtons. There's also a friction force of 1,200 newtons. Calculate its acceleration. Pen, paper, calculator. I'll show you the answer in 3, 2, 1. So there you go. So I rearrange the equation. A equals F over M. F is the resultant force. So 4,400 minus 1,200 divided by the mass, and I get 2 meters per second squared. A phrase you need to know for the higher paper, I said in the last video, I'm not a big fan of this idea of inertia. The inertial mass of an object, basically the bigger its inertial mass, the more force is needed to change its velocity. M equals F over A. I don't like that because our definition of the Newton is actually based on F equals ma. But anyway, moving on swiftly, you know what that is now. I'm going to do a whole video about stopping distance and different vehicles and stuff like that because it comes up quite regularly. Let's have a quick look at this. You've got a motorbike, you've got a mini, and you've got a bus. And basically what I'd like you to do is to work out the average acceleration using the data that I've given you and actually work out the average resultant force as well. So have a go at them, pen, paper, calculator, and okay, so the motorbike, acceleration 9 meters per second squared. That's almost like little g. That's crazy acceleration. Okay, the resultant force about 2,500 newtons. Now the mini, its acceleration is only about half a g. It's half as much as the motorbike. Okay, the force from the engine is actually bigger, but of course because its mass is a lot bigger, then its acceleration is less. The bus, its acceleration is a lot smaller. It's about 0.7 meters per second squared, which is good really, because if you were standing up in that bus, you don't really want to go flying across the floor. Okay, so its acceleration is a lot smaller. Its engine is very powerful. Okay, it's almost 3 times as powerful as the small car.